Okay, we're going to take a look at the one sample t-test, and we want to know if we can conclude that the population mean of X is less than 200. Maybe this is in seconds, the length of time it takes to solve five fairly simple math problems. But they're doing it on the computer, and we have a computer timer, so we can get that out to the hundredth of a second. So all I've done here is just record the data. X equals combine or concatenate, and I've just listed the numbers. You can put all those on one row or one or two rows if you want. I think I probably cut and paste those from something, and so they were in a column format, so I just left it that way and put some commas in. But anyway, there are our observations here. And so first thing I'm going to do is compute some sample statistics. Okay, I got to actually do that first. So the data's in now, and you can see it comes over here, the values of X, and they're listed. There's 1 to 20 of them. The mean is 189.395. And then the standard deviation, and then the length or sample size. Of course, I could have read that over here where it says number 1 to 20. But anyway, there I have it verified that I have my mean, my standard deviation, and the sample size. Then I'm going to draw some graphs just to get a look at the data. So I'm going to plot the density. And so you can look here and see that it peaks at around 190, which fits with our mean. Fairly symmetric kind of thing, a little bit of a bump over here, but fairly symmetric. And the next thing I've done here is just redo this graph. When I'm done with this first one here, this is just setting the parameters of the graph. BG stands for background, and I'm going to make the color of the background something called Alice blue, which is a really light blue. And then I'm going to plot, again, density of X, but I'm going to make the color of the line dark blue. LWD just changes the width of the line, so I'm going to a little more than double that. I'm going to take the frame plot off. That y-axt equals no. It's just going to take this y-axis off. Those numbers really aren't all that meaningful for most of us anyway. And I'm going to change the X label just to be X. And then I'm going to give it a title. I could call this, instead of X label X, instead of making the X label X, you want to make it something more descriptive. Maybe time to complete the task, solving the 5 problems or whatever. And then, of course, you would want your, you can put whatever title you want here. I'll just make it time. And so here we go, and you'll see. Now I would only do this, the light blue, that background thing, if this were part of a PowerPoint, and that's the color of the background of my PowerPoint, or something similar to that, to make it kind of match and look a little better there. I wouldn't do that in something I was writing for a paper. Okay, this next statement, device off, just turns the graph off, so I don't keep this. I start from scratch. Otherwise, everything from here on out is going to have that same background. And if you want to have that to be true for everything, then you don't need to do that right now. But you see, it just cleared things out. And now I'm going to make a box plot. And I'm going to put a line here, horizontal line at 200, because that's my hypothesis. And so now I have a way of comparing my graph, my box plot, to the hypothesized value of 200. I want to know if it's less than that. It certainly looks like there's a pretty good shot of that the mean is going to be less than that, since this is symmetric, and it should be pretty close to the median. And so the next thing I did here is, or the next few things actually, is just going to try and make that a little bit nicer looking. I changed the color to sky blue and took the frame plot away. And of course I'm going to leave that line on there. Made it a little bit thicker this time. And then this next part here, I'm just going to add some text to that. So if we're doing this as part of a presentation or something, I would have everything there. And also, it's, I think, generally good practice if you have space to put your numbers and stuff on the graph. It just gives everything there where people can see it. So the first thing I'm going to do with this 5num(x) is just get the 5-number summary. And so that's the minimum, Q1, median, Q3, and maximum there. And then I'm going to make my box plot. I just made it all that box specs thing. You see it made it narrower. I think that's the only thing I've changed so far. And then put my line back in for the mean. And now I'm going to go ahead and just write under there. It's at text 1.6. I know that the center of the box plot is around, it's called 1. Now, if you have multiple box plots, it'll be different than that. And I have to experiment myself. If I put something like 0.4 on that, you can barely see it. It lines it up by the center. So I would stay with the 0.6. Let me just go ahead and rerun that part because I don't want to have that on there. But there's nothing you can do other than kind of play around with it. At least that's what I do. I have some pretty good guesses. I'm going to add some more text here. And again, I had to play around with the X value. The 152.37, I'm going to go back up here and run. That's the median from the 5-number summary. And so I'm going to add some text there. Now I have that on the graph. And especially if you're doing a one sample graph here, you want to go ahead and put all of those numbers there, but you can just follow that pattern. I'm not going to write them all out on this one since I'm just doing a demo. In this next statement, points, I'm going at this 189.3955. That's the mean. If you didn't write that down or you need to, I usually just write those up in the console and then get it there. Again, you may have these screens in the opposite order. I changed that through the tools menu so I can type my commands here and it's just easier for me to see. But anyway, what this is going to do is it's PCH is a diamond, making it a little bit larger than the default, and I'm coloring it white. This is the background of the diamond. Well, you didn't get it all there. And there we go. We have a diamond where the mean. If you're going to put text, you probably want to put that the mean is equal to 189.355 and so on. And you might as well put the standard deviation on there as well. I don't always turn the device off, but I'm going to go ahead and do that now. Okay, so for the t-test itself, remember our t-test is based on the variable x, that's the name of the variable. Mu is 200, that's our hypothesis. We want to know if the population mean is less than 200. And so I'll put alternative equals less. And let's see, I'll change this a little bit now. So my t-test is minus 2.3284. There's my degrees of freedom, my p-value. You can see that that's 0.01. We're going to reject HO. And we have t-test of minus 2.384. Now, we know because of the p-value it's going to reject HO. But if we were doing this in a formal sense, we have 19 degrees of freedom. That's just n minus 1. A one-tailed test in 05. So if we had our t-table, we would just go over to one-tailed test 05 down to 19 degrees of freedom. And here's our t-value of 1.729. So we'll reject HO. The t-test is less than minus 1.729, which it is. It's minus 2.33 almost. So we'll reject HO on the t-test. Now, when you do a one-tailed test, alternative equal less, R gives you what's called a one-sided confidence interval. I suppose those have their use, but I prefer, and I think most people prefer, just to have a two-sided confidence interval. And since we had 0.05 and one-tailed, that would be actually the equivalent of a 90% confidence interval. So when I do a one-tailed test, I actually just rerun it as a two-tailed test and get a confidence interval of 90, and that's what I've done here. T-test is equal to x, mu is 200 still, confidence level is equal to 90, And this will give me the confidence interval that matches up with that one-tailed test. And so here we have our confidence interval will be 181.52 to 197.27. So I only run if I were doing a two-tailed test, I could just put the confidence interval in with the first t-test. But since I'm doing a one-sample t-test and I want to match up with the alpha of 0.05, I'll just run to get the confidence interval, a separate t-test, and let it know that the confidence interval is 90. Okay, for the effect size for Cohen's d, for the one sample case, I'm just going to calculate that by hand. That's the easiest thing, and I really don't see too many functions where they give you the effect size calculation for a one sample test. Just take the mean. Well, there it is. The mean of x is 189.3955. So I just type that in, minus 200. And then you're dividing it by the standard deviation. If you forget what that is, just there it is, 20.368. And then you have to, this just computes it. You have to repeat the name here in order to get it to print it out for you. I'll do that separately so you'll see here. It's calculated and it's put over here under values. And that's it right there, the minus 0.52. Of course, we'll take the absolute value of that. But if you want it to print on the console, you'll have to just rerun that again. Again, that's your effect size. It's the absolute value of that, or 0.52 would be a medium effect size, but it's between 5.2 and it's above 0.5, but still less than 0.8. And so that's the one sample t-test.